This lesson is on simplifying rational expressions. We're going to start by just talking about how we do it with different operations, and in a later lesson we'll get to addition and subtraction, but today we'll talk about simplifying rational expressions and then what happens when we multiply and divide them. So first of all, let's talk about what a rational expression is. Rational expression is the ratio of polynomials. So what that means is we're going to have an expression that has, in the fraction, it's going to have a polynomial in the numerator and in the denominator. Now, when we do that, we want to make sure that we recognize that the key steps for doing these problems is to factor and reduce. We're going to find that coming up again and again in these problems. Now, when we talk about these two operations, addition and subtraction, we'll wait till later to working with these, because with these, you're going to need to find a common denominator. So just as a preview, we'll get to that later. You get the common denominator, you can combine fractions together. We're going to focus instead on multiplication, which again the key steps will be to factor and reduce, and division, which will be to first of all do the reciprocal of the second fraction and multiply. So we're going to turn that division problem into a multiplication problem. And in the same way, we're going to then simplify it by factoring and reducing it. So let's go ahead and try some problems just to see what we're talking about here. Okay, the first problem I want to do is going to be x squared plus 7x plus 10 over x squared minus 3x and then minus 10. Now just a reminder when we do this not to think about being able to reduce these 10s here, because when they're being added or subtracted, they're not factors and we can only reduce factors. So let's take a look at what this factoring looks like. When we factor the top, it becomes x plus 5, x plus 2, and in the bottom this factors into, when we factor it, x minus 5 and x plus 2. Now when we look at those factors, what we see very clearly here is that there's an x plus 2 factor in both the top and the bottom. Well, we have to remember that anything over itself is equal to 1. So since this is now multiplication here, this is these fractions, in this fraction we're multiplying by 1, that can reduce out. So all we're left with then is x plus 5 over x minus 5. And typically when we write this, instead of writing it equal to 1, we just show it by crossing out each of the factors to show that those together become a factor of 1. Let's try another one. Let's try x squared plus 4x plus 3 all over 5x and divide that by x plus 1 and x plus 5. Let's see what that simplifies to. So let's try this problem. The first step to do on this is to take that second fraction and make it into its reciprocal and multiply. So at the same step, I'm going to go ahead and factor this one. So this becomes x plus 3 times x plus 1 when I factor x squared plus 4x plus 3 all over 5x multiplied, and let's do the reciprocal of this one. We have an x plus 5 over an x plus 1 here. Now, why that's convenient for us is whenever we have multiplication like this of two things, instead of the division, we can take and we can make it the things on the top being multiplied. So we're going to extend this out and make this a factor of the top, and this is a factor of the bottom. What that tells us now is we can look at this factor and this factor. Those two, when put over one over the other, become a factor of 1. So what we're left with is this x plus 3 times the x plus 5 on the top, over 5x. We don't have anything else to reduce. Even though this is an x and a 5, it's got a plus between it. That doesn't reduce with this 5x because that's multiplication. And now just to completely simplify, what I'm going to do is take and multiply out the top. And when I multiply it, I get x squared plus 5x plus 3x is plus 8x. Plus 3 plus 5 times plus 5 is plus 15. All over 5x, and that's my final answer right there. All right, let's try another one. So if you take those now, we take and think about how we can simplify. One of the important steps is what happens when factors are similar but not quite the same. Sometimes we can use some of our mathematical knowledge to simplify those as well. So let me try this problem. We're going to do x squared minus 64 over x squared minus 16 divided by, and in this case I'm going to make it x plus 8 over 4 minus x. Okay, let's take a look at this problem and see how we simplify it. So what I want to do first of all on this problem is take and do the reciprocal of this second fraction. And at the same time, just to save us a couple steps, I'm going to factor this one at the same time. So this one, this first numerator, that's the difference of squares, so that's x minus 8 times x plus 8. And down here, that's also the difference of squares, so that's x minus 4 times x plus 4. So factored out. Now this one I'm going to take and make it into multiplication and do the reciprocal. I'm going to have 4 minus x and x plus 8. Now, what we have here are two different polynomials here that look very similar. This x plus 8 and that x plus 8, they're exactly the same. So I can take that entire factor of x plus 8, I can reduce out, because with multiplication we can treat this as a single fraction and treat these as different factors. So those two reduce out, but notice this one looks a whole lot like these two. Now how are they similar? This is a key step. If you have a statement like this, where it is the opposite of one of these guys, you can go ahead and still reduce it. So let's write this out again, x minus 8. And I'm going to take out a negative 1 out of this. If I take out a negative 1, this becomes, I have to have that change both signs then, and x minus 4. Notice that negative 1 times x is that minus x, negative 1 times negative 4 is the positive 4. By taking out a negative 1, they've swapped places on that. Over here, I've got the x minus 4 and the x plus 4. What I want you to see now is that these two factors are the same, so they can reduce out. The critical step here is if you see two of them that are opposites of each other, so they've got a minus between and they're swapped places, they can be reduced out to be just a negative 1 left over. Now I can simplify the final answer to be x minus 8 times negative 1 is the opposite of x plus 8. And then this one down here I just have as an x plus 4. So that is our final answer for the problem. So when simplifying these, what I want you to recognize is that the key steps are to factor and reduce, change any division problems into the reciprocal and make it into one multiplication problem with one numerator and one denominator, and then to make sure you recognize when things are opposites. When they have opposite signs for both of them, you can reduce that out to be a -1. Last step I'd like to remind you of when you're dealing with these is when you're thinking about domains and ranges, remember that the domain of these, the domain is based on the original problem before it's reduced. So if we ask about what the domain is on this, look at the factored step. Here I'm not allowed to have 4, -4, and -8. And because the original division, I'm not allowed to have 4 either. So with domain, if you're asked about it, you want to look at what would make any of the original denominators equal 0. And you can't have that, so those values would be restricted from the domain. So simplifying rational expressions when you have the right ratio of a couple polynomials, multiplication or division, this is how you simplify them.